Yep, transcript getting me. Okay. All right, everyone. Let's see here. Everyone see my screen?
Yes.
Perfect. All right, so this is session 1 of the series so-called Coding with Cody. So go ahead and there we go. So this course is going to be 4 sessions. It'll be every Wednesday for the entire month of September. So these sessions are designed to hopefully allow you guys to take the code that we've given you and start enhancing and adding your own details to make your robots even more competitive. So session 1, which is today, we're just going to go over some Arduino programming basics, the setup for the Arduino IDE, and a little basic intro to electronics so you can make sure to be safe with the Arduinos. Session 2 which will be next week, is going to be the motor and sensor control. So we'll show you guys how to interface the Arduinos with an ultrasonic distance ranging sensor, and also how to drive all your motors on the robot itself. I'll also do a little intro into libraries. This is code other people have written. This is pretty important in Arduino, as a lot of times it's a lot easier to find code already out there instead of having to write all your own. And then even more, a deeper dive into electrical safety. Session 3, which will be the 17th, that will be autonomous movement and functions. So functions are we'll get more into it then, but just a quick idea. Functions are kind of like a way of using code over and over again without having to actually write it all. And then session 4 will be integrating multiple systems, loops, and the final challenge. And that will be on the 24th. So what is an Arduino? So an Arduino is essentially a little microcontroller development board. Every Arduino has in the center here a little microcontroller. This is the heart of the Arduino. This is all the processing and what actually does all your computations. All of the supporting circuitry is just exactly that, supporting circuitry, and it has all your pins and your USBs and your power inputs. Person in here. 1 second, guys. All right. Perfect. So Arduinos are open source and have very extensive community support. So if there's a sensor you want to interface it to, there's a pretty good chance that someone already has examples or libraries to make it a lot easier. And everything is programmed in the Arduino IDE and C++. So first things first, I'm going to just go ahead and give you guys an overview on how to install the Arduino IDE. So I'm just going to go ahead and walk through all the steps here. So once you go to the Arduino IDE website, which is the arduino.cc thing, you'll then find this page right here. And you'll see Arduino IDE 2 point something something. That will probably update by the time more people are watching this. But make sure you have your Windows 10 or newer, or if you're on Mac, the Mac OS or the Linux, whichever operating system you run. And then you'll hit download. It's just pretty standard installation. And I'm not going to go through that. I already have it downloaded here. Let me share the correct screen here so you guys can be able to see this in a second. See here. And that up. Sharing the right one. But this is standard Arduino, the standard Windows installation process. So you'll notice just follow all the prompts and then state where you want to download it, and then you'll hit install. I'm not going to go ahead and do that because I already have it installed. Let me share my screen back again. All right. Perfect. And then, yeah, that's the installing the Arduino IDE. It's a pretty simple process. It might be a little bit different depending on different operating systems, but yeah. Next slide. Oh yeah, so here we're going to start. I'm going to give you a quick overview of the Advanced Go Builder Robot. If you guys took the summer development courses, you will have built one of these. But I'm just going to go ahead and give a quick little overview of it just for refreshers. So here is a top-down picture of the electronics panel on the robot. So over to the left, you'll see the Arduino itself with its shield. And then you have all four of your motor controllers in the middle, and your ARM controller. This is the one that does all the control for the ARM and positioning. Then you'll see at the top, you'll have your voltage regulators, and then your bus bars. That's just a quick overview of that. And here we have a quick overview of the schematic. So a few things I'd like to point out here for programming purposes is if you zoom in, well, I can. Look here on the right-hand side, 2, 3, 4, and 5. These are pin numbers. So Arduinos have numbers on each of the pins. If you look on the actual Arduino itself, you'll see it says like 4 or 5 or D4 or D5. That means pin digital 5 or digital 4. So if you look on the right here, you'll see our PWM front left. This is the control signal for the front left motor, and that's on pin 2. This comes into play later on when we're actually programming the robots, because you need to know which pin is attached to what when programming. And then open up that. So go ahead and go over a few basic electrical concepts. These are just things we need to keep in mind while programming and while using Arduino, just to make sure we don't accidentally damage the Arduino itself, and also to avoid hurting ourselves. So polarity. Polarity is the direction of the flow of electricity. This is important in Arduinos because if you were to put the ground and the 5 volts in the wrong spots, you could possibly damage them quite drastically. So let me just see. This is also important when input, like when attaching it to new sensors, because a lot of those will have, say, a voltage and a ground pin. You want to make sure you attach those to the right pins on the Arduino, or if you put them backwards, they could possibly damage the sensor, and it could also damage your Arduino, and also it just won't work. So yeah, always make sure you double check polarities before turning it on first time. So 3.3 volts versus 5 volts. So a lot of Arduinos operate on 5 volts. The ones we use, the Arduino Megas for our robots, they operate on a 5 volt logic. All this means is the voltage that the processor itself runs on. So if you were to take a multimeter and attach it to one of the digital pins, say the pin we're using to flash an LED or something, you'll see when it's off, it's 0 volts, and when it's on, it's 5 volts. And then 3.3 volts, a lot of the newer Arduinos, stuff like the ESP32s and more advanced stuff that we're not really going to get into here, runs on 3.3 volts. It's important to keep this in mind because there are a few sensors you may interface with that are 3.3 volt only and aren't tolerant of 5 volts. So if you use one of those with our Arduinos, you'll have to add a little bit of support circuitry and just keep in mind that it might not work 100% correctly. Yeah, a few common mistakes to avoid. Reverse polarity, talking about that earlier. Make sure when you're plugging in sensors and Arduinos, you have the positive to the positive and to the ground. So say you're interfacing with a sensor, you want to make sure your 5 volts goes to the 5 volt pin on the sensor and your ground goes to the ground pin on the sensor. Short circuits. So short circuits are when you attach ground and a positive voltage directly together. So this might be, say, attaching a wire directly from a 5 volt pin or a 3.3 volt pin on Arduino directly to ground. This will have a very low resistance path for electricity to flow, meaning it'll allow as much current as they can possibly provide to go over that wire. This causes a lot of damage pretty quickly because they're not designed to hold to power more than a few milliamps. So that direct, yeah, 1 second, I'll get your question. Direct flow of electricity can do quite a bit of damage. And then overvoltage or undervoltage. So that ties back to 3.3 and the 5 volt thing. If you were to plug in a 5 volt sensor to a 3.3 volt, a 5 volt power supply to a 3.3 volt sensor, it will have more voltage than the sensor is expecting and is designed to tolerate, so it might cause damage. Yeah, do you have a sensor? Oh, do you have a question? I think your microphone might not be working.
Julie, your microphone's not working. Now speak.
Hi, baby. How are you? How's your day? Good. Yeah. What do you want to make for dinner?
Now Gonzalez's microphone's on. Just type your question, Julie, so Cody can answer.
So what is reverse polarity? It's a great question. So reverse polarity is simply when you plug in, say, the 5-volt connector, the 5-volt connection to the ground pin. So on all Arduinos and all sensors, they'll see a 5-volt and like a ground, or a 3.3 volt and a ground. Reverse polarity would be taking that 5-volt connector and plugging it into the ground on the Arduino. This simply essentially just connecting positive to a negative instead of a negative to a negative and a positive to a positive. This just a lot of like circuitry is designed to have polarity in one direction only. And if you have this in the opposite polarity or reverse polarity, it will make a lot of current flow and it'll damage things pretty drastically. All right. Go ahead, Gonzalez.
Hey, I have a question. So, and like, I would just want to make sure, because in the past, I've dealt with electronics, and I wanted to make sure that we didn't like blow any of the circuits or anything like that. So, is it necessary for like, because I have a static guard and a static mat,
Mm-hmm.
is it important to make sure we discharge and wear those when we deal with the electronics, or is that not necessary? Cody, have you seen any issues like that in the past?
So I personally haven't seen too many issues with that. I do believe, for example, in our few RDL games in the past, we've had issues with that, like on the field themselves. But from what we're messing with, what we're using, as long as you're not like on carpet, you're probably fine. But it's always a great practice to use static electricity discharging equipment. But for most of what we're doing, especially in the summer months, when the humidity is pretty high, the chances of a static discharge are pretty low to damage things. But it's always a great practice.
Yeah, because I mean, I know down at the lab, we don't have that issue with static because of the humidity, but there could be team players that are in areas that have a lot of humidity, so I just wanted to make sure that that was disclosed, if it was an issue or not. But you're saying if we have one, it doesn't hurt to wear it, right?
Yeah, no, never would hurt to wear it, but it's not strictly required.
Thank you.
Right. Got any more questions before I move on? All right. So now we're going to do just basic understanding Arduino setup. So I'm going to go ahead and share my screen with the Arduino IDE now. All right. So just get rid of all of this. Here is just what happened. I'll go ahead and make a new sketch just for double check. Let's see here. Stop sharing that one. All right. So here is just a blank Arduino sketch. This is what you get when you just go up to File and New Sketch. So to start with, I'm just going to give you a basic overview of the Arduino IDE itself. So for example, up top in the left hand, you'll see all of our command windows. So you'll see the file that just has, it'll stay up. all of your like new sketch, opens, examples, preferences. This is just all your settings what you might use when making a new one or opening one. You already started editing. Edit, this is just your standard edit, undo, redo, copy, standard application commands. Sketch. So Sketch is really your go to verify and compile and upload your code. So in Arduino code is compiled and not interpreted. So what this means is before the Arduino itself doesn't understand the raw text code, it has to be compiled into what's called machine code for the Arduino to understand it. That is what the compiler itself does. And then after compiling, you would just upload to the Arduino itself, and that will give the Arduino the code to run. Upload using programmer and export compile binary. All of this stuff is more advanced than what we're really going to get into. Include library. So this is very useful for, say, you have a new sensor you want to try out, and you download a library from online. When downloading libraries, you add a zip library, and then down here in contributed libraries, you'll show all of them pop up. For example, our main robot uses the PS2 library, so when you include that, it does that. I'm not going to get too in depth with this today because we'll go on to that into later sessions. But in a sketch, all there. Tools. So tools is where you go to select your Arduino itself. So down here on boards, you'll notice Arduino AVR boards, and that shows a big list of different Arduinos. So for example, if you're programming the robots, you'll use the Arduino Mega or Mega 2560. Say you have a separate Arduino you're using just for practice, you might have an Uno, click there, and then port. So when you plug in an Arduino, you'll see a COM port pop up. Here I have a bunch currently, but for example, mine is on COM 10, and then I select the right one, and I have an Arduino Nano connected currently, and that'll pop up. And then get board info is also pretty handy. Say you want to make sure your Arduino is actually working. It'll pop up a little window saying a little bit of information about it. Most time it's not very important information, but it will let you know that you're getting data. And then processor, this isn't too important. Essentially, some Arduinos have different main processor control chips on them, but for all the ones we're using, example, the Mega, that isn't an issue. And then programmer and burn bootloader aren't important they're important for more advanced things, but right now they're not too useful. Help. Help is a great place to look if you don't really know what the Arduino IDE is and you want a more in-depth overview. All the getting started and troubleshooting windows are a great resource. And then on the left-hand side here, sketchbook, and all of this just shows you all of your recently used Arduino sketches. This is just a better way of a nicer looking open recent window, essentially. Boards manager. This is where you can go to install like new boards. So, example, if you go out and buy an Arduino that's based on an ESP32 chip, you'll install the Arduino ESP32 boards. We won't be going too in depth with this again because we're just using the main megas that our robots are based around. And then library manager. This is where you go to install external libraries. So say all of these are example Arduino ones, but there might be one for a sensor. Say you have an ultrasonic sensor. It's not popping up currently, but you'll go and type in your sensor type, and then a library might pop up to install it. This is just a separate way of searching for libraries. Sometimes you'll find them on here, but a lot of times you won't, so you have to go online to actually find the one you need. And then debug. Debug is not supported with the Arduinos that we use, but if you use more advanced Arduino boards, it will allow you to like step through your code one line at a time. So if you're having issues, it becomes very handy. And then search. This would just simply search in the code itself. So I search setup, and then it'll show us where it's at in the code. All right. So there's a void setup and a void loop. These are what are called your main functions. So the setup function is code that runs once. So this is where you put all of your pin modes and serial starting, sensor initializations, all of the things you want to run when your Arduino turns on, but not looping or repeating. Void loop. This is your loop function. This will run indefinitely until the Arduino loses power, or until you say have an exit clause that causes it to shut down. But this code essentially just continues the loop over and over and over again. So now I'm going to show you how to just write a very simple, essentially what's called a hello world program. Hello world programs are just basic programs to show sign of life from your Arduino. So a common one in Arduinos is what's called a blink sketch. So this will blink an LED either on the Arduino board itself or an external LED. I'll show you how to do both. So a few basic functions you'll need to know for a few basic functions you might need for setup of the Arduino is, for example, a pin mode. A pin mode just allows you to say set up a pin as an input or an output. So for an LED, that's obviously an output because we are sending it a signal to control it. So also another thing about the Arduino IDE, the new version anyway, it will show you what the different parameters for a function are. So here you'll see unt8_t pin. That is a just a variable type, which is an 8-bit integer. We'll go into that in a little more depth here later. And then the pin. So this just says what pin do you want to put the pin mode to? So for my example, we're going to use the built-in LED to the Arduino. So some Arduinos have built-in LEDs, some don't. But an easy way of finding out is just to type in LED built in, and then when you compile it, it'll either throw an error or it'll compile successfully. So it's an easy way of finding out. And then you'll hear mode. So mode, that is either output, input, or sometimes more advanced situations, maybe an interrupt input or like an analog input. But for our use case, it'll just be an output. Another great practice in writing code is always comment your code. So in C++, to comment your code is just 2 slashes, and then everything you put after those slashes won't actually affect your code itself. It'll just add comments. So when you come back in a few months, you try to figure out why the code doesn't work, you'll be able to understand what each line does. So for this line, we might write something like sets LED on Arduino to a output. And then now we come down into the loop. And this is when we start actually, this code will run indefinitely essentially. So the first thing we might want to do is set the LED to on. So to set LED on, it is something called a digital write. So a digital write is very simply a write at either a 0 or a 1. So for a 5-volt Arduino, which is what we're using, it's either a 0-volt signal or a 5-volt signal. And a lot of digital electronics, they might not say voltages. They might not say 0 volts or 5 volts or 3.3 volts. They'll just say low or high. That's just an easier way of abstracting away from the voltage itself to understand what the signal is doing. So the first thing first, we need to set our pin, which is the built-in LED. And then we'll set that to high. And that's just turning it on. Comment. Now next, if we just now put a digital light and turn digital right and turn the LED to low, you wouldn't actually be able to see the LED turn on. The Arduino runs at around 16 megahertz, which is 16 million clock cycles a second. So if we were to have that turn on and then immediately off, it would be so fast that you'd have to have a very high-speed camera to even see it turn on. So that's why we put something called a delay in. So a delay just tells the Arduino, hey, don't go after this line of code for a certain amount of time. So we'll put this as a delay for 1 second, which the delays on Arduinos are in milliseconds. So it's 1,000 milliseconds per each second. So that's why it says 1,000 here. And then we will turn the LED off with another digital write. And then we're turning that to off, which is low. So again, low just means 0 volts or off. Oh, don't forget comments. Oh, another thing I forgot to mention on C++, you have to attach a semicolon to the end of each line for commands that is normal code. That just tells the Arduino, that just tells the compiler when it's turning all this into machine code that after the semicolon, this function is over and to set up for the next one. This turns the LED off. And then yet again, we have to have another delay because since this is a loop, if we were to not put another delay, you would never actually see the LED turn off because after this line of code and it gets to the end of the serial brace right here, then it'll go back up to the top and just ride it right back to high again. So we're going to put in another delay for 1 second. All right, so now we're going to go ahead and compile this code and upload it to Arduino. So go ahead and swap. I'm using an Arduino Nano. So go ahead and hit Arduino Nano. And then on COM10, I do want to show you guys a little trick. If you have a bunch of COM ports like I do and you don't know which one's your Arduino, you can go down and search in your search bar and find Device Manager. Let me share that for you guys. And then say when you go down here to ports and COM, you'll see a bunch of just standard show of Bluetooth links. These are just what's happening in Windows background. But you notice here, serial USB CH340. That is for the example of the serial chip that my Arduino uses. But this just essentially shows you what every serial COM port is. A lot of official Arduinos will pop up in the Arduino IDE showing what kind of Arduino it is or like what the COM port stands for. But that way, if it doesn't, like mine doesn't, you can go in there and it'll show you a little bit extra information. Right? So now we're going to go over here into Sketch. You can go to Sketch and then verify/compile, or you can find a little check mark right here, which is just another, which is a shortcut to the verify. So down here on the output, it says compiling Sketch, and then if everything's successful, you'll see it says like Sketch uses so much of the storage space and how much variables you're using. I'm gonna go ahead and show you guys what it looks like when you have an error or something. So I'm gonna just go ahead and take this semicolon here off on the delay, and then verify again. And if you notice down here, you'll see a bunch of red text. It says like in function void loop, it expected a semicolon. So it's pretty straightforward there. It'll show you exactly what it saw wrong. Sometimes on more abstract errors, say I misspelled that, it might not give you as direct of commands. So notice that here it says LED misspelled built-in was not declared in the scope. That just means it doesn't know what to do with this text. Luckily, it's pretty smart and it'll show you, hey, you might have meant like actually LED built in. And you're like, oh yeah. So you fix your typo. And then verify it again to make sure it'll actually compile. Perfect. So now to upload the sketch, you will click on the little arrow, or you can go up here and Sketch and upload. It does compile it every time before you upload it. So you don't necessarily have to actually press the verify to compile button every time. All right, we're done compiling. I'm gonna go ahead and swap cameras so you guys can see my Arduino. 1 second. Perfect. So if you look down here, the LED built into the Arduino itself is flashing. And on and off 1 second. So perfect. It worked how I wanted it to. Swap back to that. Perfect. So now I'm going to show you guys how you might do it, say, to an actual normal digital pin. So to say you have an LED on pin digital 2. You don't have to put the D or the A. For digital pins, you don't have to put the D in front of them. But if you're using, say, an analog pin like A1 or A2, you will have to put A1 or actually put A1 or A2. But since this is just a standard pin, we can just do that, upload it. Because it compiles it every time before we upload it, we don't actually have to press compile. Perfect. And then again, swap cameras. Perfect. So now you notice the LED that I have attached to my Arduino is now flashing on and off 1 second. All right. So now I'm gonna show you guys just a few more basic programming things you might come in pretty useful. So the first thing is something called a variable. So variables are just a way of holding a number or a value in something that's not actually the value itself. So say you have to, for pin mode 2 here, for pin 2, you don't have to type in 2 because you don't remember what 2 is every time. So you can come up here and say an integer, int, which means an integer. And an int in Arduino is just any number between 0 and 255. So it's any 8-bit value. So we'll say integer or int pin, no, LED pin. And then we'll set that equal to 2. And then always make sure you put your semicolon afterwards. So that way, when we're writing our code, we don't have to remember which pin everything's attached to. You can just go down here and type in LED pin. All of this, same places you would put your normal 2. And that way, when you compile it, it'll still work like just the way it did a minute ago, but now you don't have to necessarily remember every pin number. Right now, that might not seem very useful when we're just doing one LED, but say later on when you have a whole bunch of sensors and a whole bunch of motors attached to your robot, it's a whole lot easier just to type in like front left motor instead of having to remember which pin the front left motor was attached to. Just again. So let's see here. Oops, all that. Another type of variables, there's a few more types of variables you might come into. So if you have to deal with a floating point number, which is any number with a like decimal, so like say like 2.1, you'd have to use something called a float. And then there's also things like strings, which is just anything that holds, for example, a text value. So say you have like you want to type something to your screen, or you want to have like a normal text, you can just like say text. That'll allow you to have what's essentially a bunch of text. Get rid of that. Another thing that's pretty handy in Arduino is Arduino can write to the serial monitor. So the serial monitor allows you to write code, like put like debugging code that will then pop up on your computer screen so you can see how everything's running. So just a basic example on how to use serial, you can just go into serial, type in capitalized serial, and then setup or start, actually. Sorry. No, begin. And then you'll type in something called the baud rate. The baud rate is essentially how fast or how many bits it's sending per second. So if when you open your serial monitor, you'll notice, for example, down here it says baud rate. And there's a whole bunch of options. For our uses, 9600 is perfectly fine. If you're like doing a bunch of data, you might want something slightly faster. But for this, there's no need. And then say we want to write to the serial monitor every time we change the status of the LED. We'll go serial and then print ln, which means it will send a new line after every time it prints. And then we'll just print LED on. Then do that. And then we're going to just copy and paste this down below here. And we'll change that to LED off. I'll show you guys what this looks like. So yet again, upload it to the Arduino. And then when we come down here to serial monitor, you'll notice every time the LED turns on and off, and I'll go ahead and show you that so you can see it, that every time it says on, the LED is on, and every time it says off, the LED is off. This is very useful for when you're doing autonomous code in your robot. So you could prop it up on a set of blocks and make sure that when you send a command to say turn right, all the motors are doing what you want them to turn right. It's also good when you're interfacing with new sensors. So say you have an ultrasonic distance sensor and you want to make sure everything is working, you can just write all of your output or your data you're getting from the sensor to the serial monitor, and that will allow you to see the distancing and the raw values, so you know what you're working with when you go to write all your logic code. All right. Yeah. And start screen sharing the presentation again. So the Hello World program, we did all that. So yeah, here's another basic overview just to recap. For creating a basic LED blink program, you have to start with initializing your pin. So that is the pin mode command. You have to set it as an output, and then you'll set that pin high or on, which is to turn the LED on, and that is the digital write. And then you'll have to delay and then turn it off. So that's about all I had to cover in session 1. Just starting with Arduino and familiarizing yourself with the Arduino IDE. I would recommend everyone go and download the Arduino IDE and start playing around with it. Just make sure you can know what all the commands look like, all the buttons look like on the Arduino IDE, because in later sessions, it'll get pretty in-depth pretty quickly. So you need to know, make sure you can compile and do all the basics. So anybody have any questions? Yeah. Nobody? Well, that's about all I have for today. Next week, we'll go ahead and start getting
Yeah.
into.
I have a question.
Yeah, go for it.
So I saw you were making it blink. I know in the competition there could be specific challenges that may require us to do specific tasks, right? So like,
Mhm.
would that be something like that could possibly be done where like maybe we would have to take a robot and flash a light to a sensor or a drone? And that's the other piece of this is like, I know we've been talking about the robot for a while now, but don't we have to do an autonomous portion for the drones too, or is that not something we have to do?
Yeah, they will be autonomous things for the drone as well. Programming those is a little more out of the depth, out of the, not working over here, but like they sometimes have to autonomously fly and such. But the robots themselves, the autonomous, I don't think we've ever had like a flashing a light or anything like that at a sensor. But the main reason I showed you the blinking LED is just to familiarize everyone with the like common Arduino commands. But those basic commands can do a lot more than just blinking LED. So say a lot of sensors or like motor operators, they might only have like 2 positions. So you may have, say, a claw that just runs off of a standard voltage. That might need to be 5 volts for open or 0 volts for close. That's something you can use that for. But I essentially just showed you the blinking LED just to give a basic, simple Arduino sketch to familiarize everyone with all the terms.
Thank you.
Mm-hmm. Any more questions? All right. Well, next week we're going to be going over a little more in depth. I think we're going to double check everything I'm about to say. I'll put it in the right window again.
Cody, can you hear me?
Yeah.
Before, I was trying to respond. Can this one be downloaded to like Chromebook for like the cadets?
So you can't download the actual Arduino IDE. There is an online version. I'll go ahead and show you that really quick. So if you go into Arduino IDE online, there is the Arduino Cloud Editor, which essentially allows you to do everything that you need to. I have to sign in 1 second. Let me go ahead and get this working, and I'll show it to you. Yeah, the online Arduino IDE just allows you to do, I think, almost everything that the full computer variant does. Second. I'm confident it's working. Okay. Perfect. Let me just share the screen again. Share this window. So the Arduino IDE, it's a little bit different, but it still allows you to create sketch. So you can say create new, then a sketch, then yeah, allow us to do all that. And you'll notice it has the same setup and loops. And you'll have to think down a few plugins to make everything actually work, but it'll allow you to program robots from the web. I haven't personally tested it on our Chromebook, but you should have no issue getting it to work on our Chromebook.
Okay.
Any more questions? I'll go and give you a sneak peek into next week. So for a recap, next week we will be, I don't know what I'm talking about here. Yeah, so motor and sensor control, libraries, and electrical safety. So we'll just be going, showing you guys how to control the PWM motor drivers on the robots and also sensor control. So we'll do a basic little introduction using a ultrasonic sensor, which is a type of ranging sensor, and then libraries, which will go into the sensors. So essentially, we'll use a pre-existing set of codes to make our life a little bit easier when programming the sensors. We'll also go ahead and a little more in depth into electrical safety. But that's all I have for now. If no one else has any questions, this will be it. Thank you guys all for coming.
Hey guys, just real quick, thank you guys, as Cody said. Cody, great job, man. Really doing a good job. Now, he is scheduled and being paid for 2 hours. So just know that if you need, especially as your team start to program the robots and you start encountering problems, Wednesdays from after he does his little session from 4 to 5, thereabouts, he will be available to you if you need to do some troubleshooting. So, and I can promise you, you're going to need him. Okay. So, but again, Cody is a starving college student from Cookeville at Tennessee Tech. I'm just kidding. This kid has his own apartment. So as a sophomore, he's a rock star there in Cookeville, Tennessee. But the benefit of having Cody at your just know that that's pretty good. That's big time, right? Because you're going to need that help and that support. But as always, we appreciate you. We're grateful for each and every one of you. And the ultimate goal is when you guys get to competition and you start having problems, is your kids are turning into Codys, right? And that's our goal. That's what we want, is for them to be able to create their own innovative solutions to the problems that they're incurring. Hey, there's Steve, right?
There we go. And I'm in grandpa mode right now, so I have to keep my mute on.
That's the most important mode to be in, right there.
Yeah, you bet.
Julie,
I wish I could have come in earlier, but it sounds like
background.
Cody's got it under control.
He does. That microphone's doing wonders.
Fantastic.
Yeah.
So, Cody, maybe next week after the sessions, I'll show you what my robot does. As far as the just being, the motor, and also yeah, that's just really what it's doing, and I haven't seen that one do it before like that until a couple of days ago when I turned it on and tried to work on it.
What's it doing, Sergeant First Class?
So then is when I turn it on, the functionality comes on, but when I connect the controller, um, right after I push the R1, the motor to the left, both front and back, starts to actually have signal in it goes in reverse, very very quick reverse.
Okay. Okay.
But when I try to go forward, it does. When I try to go forward, it goes forward, but in a slow motion because I think it's trying to compensate for being reversed. On the
Okay.
right side, it actually sometimes you just kind of have that glitch, like it goes forward, and it does give me the ability to go forward when I actually hit the forward.
Gotcha. Okay. Yeah, definitely sounds like a mapping issue with the controller, but I'll let Cody take that one and
Yeah.
we'll get a total shot. So
I'll show that one next week, and you'll see what it does.
cool.
Alrighty.
Yeah, and hey, that's a great idea if you guys want to pull out your robots. And I noticed, I think we've got some students here, which is even better, right? So make sure that you guys are doing some live demos with Cody here, and he can actually see some of the the problems and then offer remedies via teleconference, because I know everybody's all over the place. We got, looks like Christopher is in Germany, so it's nightfall there, right? Yeah. Thank
Yes,
you for
it's
staying
about
up so
almost
late.
11.
Oh wow. Well, God bless you, man, for staying up that late. My bedtime's 9. My wife has me out walking at 5 a.m. every morning. So
I
that's
appreciate
awesome.
this very much. Thank you.
Hey, you're welcome, man. Anytime. And these sessions are recorded. So what we're going to do is we'll make these available, probably give us a little bit of time, but we'll have these on a special section of the robotdroneleague.com website so that you guys will be able to access them at any time and go back and say, what did he say? Hit pause.
Thank
Yes,
you.
that would be good. So I could show a couple of my students that are my programmers. So
Yeah, absolutely. And this is always, the heavy hit item with coding. But we've done some videos in the past with some of our kits, and sometimes you can find those online at our YouTube channel. But again, I think we got Cody a real microphone this time, so we're going to be able to hear him. But just nothing replaces the in-person help, because that's what matters.
Thank you. See you guys next week.
See ya.
great. Thank you.
Hey, you're welcome. Julie, you okay? Your microphone not working? I got you. Cool. Well, thank you all. Good job, Cody.
Yep.
Thanks,
Thank you all for
Cody.
coming.
Great job. See ya.
Thank you.
I'll let you end it, Cody.
Alrighty.
You doing all right?
Yeah, doing pretty good. How about yourself?
Doing good. Doing good. Writing up online